Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 29, multi-step problems, all operations, addition, subtraction, multiplication, and division. So here's our first example. The school librarian, Mr. Marker, knows the library has 1,400 books, but wants to recognize how the books are displayed on the shelves. Reorganize how the books are displayed on the shelves. Mr. Marker needs to know how many fiction, how many nonfiction, and resource books are in the library. He knows that the library has 4 times as many fiction books as resource books, and half as many notification books as fiction books. If these are the only types of books in the library, how many each type of books are in the library? Draw a tape diagram to represent the total number of books in the library. Okay, so the tape diagram would simply be a diagram of a piece of tape with 1,400 being its value. Now it says draw 2 more tape diagrams, one to represent the number of fiction books in the library, and one to represent the number of resource books in the library. So if I start with resource books, and I look up here at fiction and resource, it says he needs to know how many fiction, and 4 times as many fiction as resource. So if I make resource a box this size, and there's 4 times as many fiction, I need 4 of these same size tables on my tape diagram. So there is fiction books. What variable should we use throughout the problem? I will use R for resource book. Because it represents the fewest amount of books. So you always start with the fewest. Okay. Write the relationship between resource books and fiction books algebraically. Okay, so if R is resource books, then fiction would be 4 times R. So with respect to R, the fiction books would be 4R. Okay. Draw a tape diagram to represent the number of non-fiction books. Okay. Now if I go back, non-fiction book, resource books, and half as many non as fiction. Half as many non-fiction as fiction. Well, if there are 4 of these fiction books, half of that would be 2. So a tape diagram for non-fiction would be 2 squares, or rectangles. Okay, and I just explained how I determined how that would be, because it's half as many as the fiction, and the fiction can represent the number of non-fiction books in the library algebraically. Okay. Non-fiction, going back looking at our diagram so far, R is resource, 4R is fiction, and half of that is non-fiction, so half of 4R is 2R. It says use the tape diagrams we drew to solve the problem. So if we start out with that original tape diagram we had, that was our total, 1,400. And we're going to split that up among the resource, fiction, and non-fiction. And if this is R, and then 1, 2, 3, 4 of them would be 4R. And then finally, let's make this a little bit longer. Half as long as this piece here, and call that 2R. So this is non-fiction, and now I should have this equal to my total length, so let me change that a little bit, because the total has to be the same. So 1,400 is represented by resource, and the 4R is fiction, and the 2R is non-fiction. So resource plus fiction plus non-fiction equals the total. So now we can write an equation now that we've labeled this, and it would be R plus 4R plus 2R equals 1,400. It says to determine the value of R, so we combine like terms. 1 plus 4 is 5, plus 2 is 7. 7R equals 1,400 looks. And if I solve this, divide both sides by R, then R equals 7, 200. Divide both sides by 7, R equals 200. Okay, so we know there's 200 resource books. Now we can answer the rest of the questions. How many fiction books are in the library? Well, fiction was 4R. 4 times the number of R, so 4 times 200. Fiction was 4R, so 4 times my R equals 800 fiction books. How many nonfiction? So if I go back and look at my diagram, nonfiction was 2R. So 2R is the nonfiction, which equals 2 times 200, which equals 400. Set up a table of 4 columns and label each column. So if I said fiction, nonfiction, resource, and total would be my table setup. Okay. So here's our table starting fiction book, nonfiction, resource, and total. And then it says to continue this, we would then fill in our table. We know that's 1,400. We know that fiction was 4R. We know that nonfiction was 2R. And resource was R. And I could change this. I guess I can't, I'll erase it. So that, let's change that to a variable. That total is 7R. Okay, so put another row in our table. So if R were to equal 100, there'd be 4 fiction books, 2 nonfiction, 1 resource, and 7 total books. If we substitute another value in for R, let's say 5. Say there were 5 resource books. 5 resource books. So if I put a 5 in for resource right here, 2R would be 10, 4R would be 20, and the total would be 35. We can continue this. So how about we go up to, say, 200, or say 50 resource books. Nonfiction is 2 times that, which is 100. Fiction is 4 times 50, 200. 200 plus 300 plus 50 is 350, or 7 times 50 is 350. And then we just keep going up until we find the total. So if we had 200 books here, nonfiction would be 2 times that 200, or 400. 2 times 4 would be 800. And 800 plus 400 is 1,000. 200 plus 200 is 1,400 books. So then it says how many fiction books are in the library. Fiction is right here. How many fiction books are in the library? That would be 800. How many nonfiction? Nonfiction is right here, 400. And resource books, 2. Does the library have 4 times as many fiction books as resource books? The answer is yes. 800 is 4 times 200. 400 times 200. Does the library have half as many nonfiction as fiction? Yes. 800 divided by 2 is 400. Actually 400. So it'd be 400 divided by 2, which equals 200 books. So when I add these all up, 400 plus 200 plus 800 is 1,400. Okay, so here's an exercise. Solve each problem below using tables and algebraic methods, then check your answers with word problems. Indiana Ridge Middle School wanted to add a new school book. Add a new school sport. So they surveyed the students to determine which sport is most popular. Students were able to choose among soccer, football, lacrosse, or swimming. The same number of students chose lacrosse and swimming. So the same number of students chose lacrosse and swimming. So off to the side here, I would say L equals S. The number of students who chose soccer was double the number of students who chose lacrosse. Okay, so now we have a problem with our variable, soccer, swimming. They could have chosen a sport that didn't start with the same letter to make this easier for us to label. So I'm going to use F for football. So soccer in Europe is called football. So I'm going to use the letter F for soccer. So the number of students who chose soccer was double the number of students who chose lacrosse. So football equal 2L. The number of students who chose football, fantastic. I can't use F now for soccer. Okay, so soccer. What could we call soccer? Lacrosse, swimming. Let's just use R for soccer. Ends in R. And then football. Number of students who chose football was triple the number of students who chose swimming. So F equals 3S. This is just thinking on the side, getting this all set up. And so if we list this, S-O-C-C-E-R, and say football, lacrosse, swimming, and total. Okay, so if I set this up, okay, so if we start with the lowest, lacrosse and swimming are equal, they have 1. Soccer has 2 times L, or 2 times S even. And then football is 3 times. So here's our setup. So if I total that, I get a total of 7. So then when I add to my table, okay, so we have 434 students completing the survey. So if I know that this is 434, and I divide that by 7, so I take 434 divided by 7. 7 times 6 is 42, and 2. So that means that if I divide the total by this total, I get 62. So 62 represents 1 person. So if I multiply 7 times 62, I get 434. Multiply 1 by 62, I get 62. 62 times 3 is 186, and 62 times 2 is 120. Okay, so doing it with a table, I think, is pretty much the easiest way to do this. All right, number 2. At Prairie Elementary School, students are asked to pick their lunch ahead of time. so the kitchen staff will know what to prepare. On Monday, 6 times as many students chose hamburger as salad. So I'm going to say hamburger and salad. The number of students who chose lasagna was 1/3 the number of students who chose hamburger. 225 students ordered lunch. How many students chose certain options? So here's my table. So if I say 6 times as many students chose hamburgers as choose salad, so I have a salad 1 and I have 6 chose hamburger. The number of students who chose lasagna is 1/3 the number of students who chose hamburgers. 1/3 of 6 is 2, so my total is 9. Okay, so there's my table set up. And now I know that the total is 225. So if I take my 2 givens and see how many times 9 goes into 225, 9 times 2 is 18, leaving 45 as a remainder, and that's 9 times 5 is 45. So now I know I multiply everything by 25. 25 times 2 is 50. 25 times 1 is 25. 25 times 6 is 150. 150 and 25 is 175. 50 is 225, so my totals are correct. So here's my table. So let's answer the question now. How many students chose each option if hamburger, salad, lasagna? Only 3 options. 150 chose hamburgers, 25 chose salad, 50 chose lasagna, totaling 225. Okay. Now, next example, 3. The art teacher, Mr. Gonzalez, is preparing for a project. In order for students to have the correct supplies, Mr. Gonzalez needs 10 times more markers than construction paper. So I'll start with markers, construction paper, he needs the same number of bottles of glue as paper. So I'm just starting with my topics, my headings, and scissors. Okay, and total. Okay, so here's what we have. We know we have markers, construction paper, glue, scissors, and total, and we know the total is, if Mr. Gonzalez collected 400 items for the project, that's my total. How many of each supply did he collect? Now we look at the amounts. Mr. Gonzalez needs 10 times more markers than construction paper. So I put a 1 there, 10 times 1 is 10. He needs the same number of bottles of glue as pieces of construction paper, so glue is also 1. The number of scissors required for the project is half the number of construction paper. So now I don't want to deal with fractions, so because this would be half of 1 is a half. So if I double a half, that's 1. If I double 1, that's 2. And if I double markers, that's 20. So now I'm going to move this total down to the next row. I meant to put that below here. I total what I have here, which is 2245. That's 25. Okay, so now it's all coming together. So now I have 400 divided by 25. 25 goes into 100 4 times. So this will be 1 times 25. 1. Okay, so when I do this, I get 150, and that would be 6. So it's 16. So 16 scissors. Double 16 is 32. 32. 16 times 2 is 16 times 20 is 320. 320 plus 32 is 352. Plus 32 is 384. And 16 is 400 items. Okay. Last example. The math teacher, Miss Zenz, is buying appropriate math tools to use throughout the year. She's planning on buying twice as many rulers as protractors, so I go rulers, protractors, calculators, and total. Okay, the total is 65 that we're going to come up with. Okay, she's planning on buying twice as many rulers as protractors. So if protractors is 1, twice as many is 2 rulers. The number of calculators she's planning on buying is 1/4 the number of protractors. 1/4 calculators. So 1/4, I don't want a fraction, so I'm going to multiply this by 4. And if I multiply this by 4, I get 4. And multiply this by 4, I get 8. Okay, so I'm going to turn this into whole numbers. And 8 plus 4 is 12, plus 1 is 13. 13 goes into 65. 5 times 3 is 15. 5, 6 minus 0, and it is 5. So if I multiply 13 by 5, I get 65. 1 times 5 is 5. 4 times 5 is 20. And 8 times 5 is 40. 40 plus 20 is 60, plus 5 is 65. So we have 40 rulers, 20 protractors, 5 calculators, totaling 65 items. And that, my friends, is the end of lesson 29. Go do your problem set.